Hello my dear champions, welcome back to our channel Deeksha Karnataka. So today I am here with very special session because all of you been asking us in different lectures comment that when is going to be the next class in KCET sir. So this is your next class in KCET, your top 30 PYQs KCET Math integrals, one of the important chapter which is there. I wanted to add some more questions into this, so that's why I have brought this back, high weightage and difficult at the same time, and you all have been asking me again and again in the live as well. So integration is difficult, how to deal with it, there's so many PYQs, so that's why I have taken it back. One more thing, every weekend now you'll have a class in KCET, so don't worry, we have not forgotten about that. So we'll bring more and more lectures in CET as well. Okay, so I hope you understand what we're gonna do right now. The top 30 PYQs, and they are very much challenging. I have added more and more questions. You'll see that it's not going to be like the previous sessions. I have added extra and different problems in the PYQs and KCET Math. Of course, you know this is me, Ankit sir, taking care of mathematics on our channel, and integrals is there. Okay, so let's start now. So first of all, if you all are writing for KCET, then you need to know that you have a very important exam to cover and secure good marks in, which is PU2 boards, right? Because to build the KCET rank, you need the good score in your PU2 boards, right? And for that, we have brought back a very important series, PU2 Target 90 Plus crash course. Again, online version only is available in this. So what you're gonna get in this session, in this crash course will be your one-shot lectures will be there, your complete PYQ lectures will be there, you have PCMB, Kannada and CS as the subjects available, and your lecture notes and PDF will be given to all of you, and live doubt solving will be there. You have dedicated WhatsApp community, and you have test series of PU2 at the same time. Okay, the lectures will be in live and recorded format, you will see that, and all of this is available at the price of 999. Okay, so we have made it affordable so that everybody can benefit from this, because bacha, what happens, no, if you can't score good marks in PU2, your chances of getting a good college in engineering goes away. So that's why this is the first priority. And if you're writing KCET, you are writing PU2, and this has to be given preference, and this has to be given equal importance, because the weightage is 50% and the syllabus is easier. So actually more importance should be given at this point of time to your PU2 preparation, and that's why this crash course has been given to all of you. Okay, so I hope this is all right. Yes, let's start the session now. Now this is, you can see here, looks like a form of particular function, but we have to make some changes to make it happen. Okay, and of course it is a definite integral, so we have to see if I'm making a change of substitution, I have to make the change of limits as well. Okay, so let's be careful in that and get the result. This is a mistake, we're gonna remove this. There's no integration over here in the result. Yeah, chali. So let's continue. So what is the answer going to be? I can see if I divide by cos square, I'll get sec square in the numerator and I'll get tan square in the denominator. That makes sense, right? Tan square, if it's there, I can use the substitution of tan as t. Okay, so divide everything by cos square x. So I'll end up with what? Sec square x dx upon a square tan square x plus b square. Okay, integration is there with 0 to pi by 2. Superb. So we also need to take this a square common, so I'm going to just do that. Limit continues with the same values, upper limit, lower limit, sec square x dx. Why? Because we are making free the coefficient of the variable form. Okay, it has to be only one, that's why tan square x, and over here I have b square upon a square. Next comes your substitution and change of limits. Take this out. Tan x is going to be t. It means your sec square x dx will be dt. I hope you know by now how we are using the change in the derivative part of substitution. Okay, now limitsing. So when x was 0, t will also be 0, right? X is 0 means tan 0 is 0, but when x is pi by 2, t will go to what? Infinity, right? Because when you put tan in pi by 2, t will become infinity. Now we can apply the change of limits and change of limit and the change of substitution. So what I'm left with is 1 by a square. We have to go from 0 to infinity now, and in this this is nothing but your dt, and over here we have t square plus b by a the whole square. Now we know the formula of this. We're going to use tan inverse over here. So 1 by a square outside, tan inverse over here, tan inverse of, what is this? Okay, 1 second, I missed something. Apart from 1 by a square, I'll also have something, right? 1 by a. What is a in this case? This particular form. So 1 by b by a. Tan inverse of what is it? The value t upon b by a. From where to where, bacha? From where to where? From 0 to infinity. From 0 to infinity. Check here. This a and a is cancelled. I have 1 by ab left. Tan inverse is there. Tan inverse. And if you put infinity over here, this will become simply infinity. And over here, you'll have what? Excuse me. Minus sign for the lower limit. It will be simply tan inverse of 0. Correct. Now, if you put infinity in place of t, this whole thing becomes infinity. So tan inverse of infinity. If you put for 0, you'll get what? You'll get tan inverse of 0. So this is nothing but 0 only. So I have so far AB. This whole thing will become what? Pi by 2. Tan inverse of infinity is pi by 2. This will be simply 0. My answer is coming as pi by 2 and this AB. The pi by 2AB. Pi by 2AB. So option C is correct. Option C is correct. So question number 1 is a very beautiful question which uses a definite integral, also uses a particular function. So you can see questions from this chapter will not be just on one topic. They can be club of multiple concepts, and hence the problem will be like this. 2017 PYQ. This is clear? Question number 2. Okay, this is again a particular function x square plus 2x plus 5, but it is very, very simple because in this kind of question you have to just make perfect square. Just let's do that. X square 2 into x into 1 plus 1 square. Then we have left with only 4 in the root. So I have x plus 1 the whole square plus 2 square in the root. We have this integration, right? What is the answer? X plus 1 by 2, and will become what? Same thing, the root will repeat, same root will repeat. This one, x square plus 2x plus 5. Then you'll have what? You'll have a square by 2. So in this case a square is 4, so 4 by 2, and the log function will repeat with x plus 1 and the same root. Please check. Okay, so this same root will come over here. So my answer is nothing but x plus 1 by 2 this root, x plus 1 by 2 this root. Okay, other form doesn't have x plus 1 only, so option B is the only correct choice. Please check. Okay guys, as I said, only step is to make the perfect square. Rest will be very, very simple and easy to get. X plus 1 by 2, the same root repeats from here, and 2 will get 4 by 2 is 2, log of x plus 1, and the same root repeats. Okay, super. So as I said, some questions will take time to solve it, but others will be also easier at the same time. Okay, next 2 is done. 3. Okay, this is a very good question. We're going to use what? Whenever you see this kind of question, minus pi by 2 to pi by 2, try to think whether you can make even odd work or not. If we can't do that, use something called as King's rule. Okay, what do you do in King's rule? Add the limits, subtract the variable from there, and replace x by that. So you're going to replace x by, this will be cancelled, right? So you're going to replace x by minus x. Okay, so take this out. This is my first equation first of all. I can write this as integration, right? So integration I equals to minus pi by 2 to pi by 2 and dx upon e power sin x plus 1 is my equation number 1. Now next I'm going to use this change of the King's rule. Check it out. For that, what will happen? Limit will remain same. In the integration, limit will remain same, minus pi by 2 to pi by 2. Okay, and replace just this x by minus sign. Okay, minus x. Okay, so we'll get e power sine of minus x plus 1. Now if you know, sine of minus x is what? Minus sine x. It's an odd function. It will be minus sine x. So I can remove this and write it as minus sine x. I hope you can see what is happening over here. I'm going to take product of e power sine x in both sides. So I'll end up with what? Have a look. Limit remains same. Here as well. I'll have e power sine x in the numerator. If I'm multiplying e power sine x in both numerator and denominator, this will become 1.
and this will be e power sin x. Of course, dx is there. This is my equation number 2. What did I do? I multiplied both of these with e power sin x and e power sin x. Okay, why did I do that? To make the denominator same. Check here, this denominator and this denominator is same. These two are exactly the same, sir. That's what I did. Okay, next step. Once this is done, I can add these two equations, right? So add 1 and 2. I'll get I plus I is 2i. Okay, I plus I is 2i, and I'm ending up with what? I'm ending up with, check here, e power sin x and e power sin x plus 1, and we have over here e power sin x plus 1 dx integration. Okay, so this is cancelled right here. This is minus pi by 2 to pi by 2. Check this out. 2i equals to integration of simply dx is left, minus pi by 2 to pi by 2. What's the answer? Pi by 2 plus pi by 2. Correct, now? Because I'll have only x left over here. This will be another limit, this value. So pi by 2 plus pi by 2. This integration is what? X from where to where? Minus pi by 2 to pi by 2. So that value will be pi by 2 plus pi by 2. I'm getting 2i equals to pi. From here, I equals to pi by 2. My answer is this. Option C. Option C. Now, I know this question took time, and you all will be, very much eager to know or already know that there's a trick behind this question. So whenever you have a King's rule problem and something like this is forming, don't do anything actually. You don't have to do all these steps. Simply, take the difference of limits. So write upper limit minus lower limit divided by 2. Check here. Upper limit is what? Pi by 2 minus pi by 2. Sorry, minus of minus pi by 2. So plus pi by 2 divided by 2. So pi by 2. Getting my point? So if a question is making a form of what? King's rule, you can simply apply like this. Pi by 2 plus pi by 2 divided by 2. Answer is pi by 2. So one step is enough to solve the question. You can solve this question within 1 to 2 seconds. But the approach I have also given here to help you understand the problem. Clear? Question is actually only 2-second problem, but I've given you all the necessary steps also to understand if somebody is not getting the reason behind it. Getting it? So there are two methods. One method is the whole method, other is the trick method. Done? Clear? Okay. Question number 4. Question number 4. Same thing in the same approach, because if you apply King's rule to this, you'll get what? Replace x by sum of limits pi by 2 plus 0 minus x. So replace x by pi by 2 minus x, and we all know cot of pi by 2 minus x is nothing but tan x, and vice versa. So this tan will become cot once in the numerator, and this cot will become tan, this will become cot. So you'll have the same denominator and same numerator. That will cancel. So what is the answer? As I said, upper limit minus lower limit by 2. What is upper limit? Pi by 2 minus 0 by 2. What is that? Pi by 2 by 2. What is that? Pi by 4. Getting my point? If you are not, just do the same approach what I did. Do the whole thing and you'll get the same result as pi by 4, which is option number A. Okay guys, making sense to all of you? Okay, next question number 5. Next is question number 5. Okay, we have gi of x. We have greater integer function of x under the limit of 0.2 to 3.5. Of course, I need to break it down, okay, based upon the definition of gi of x. We all know this very well. It is like this, open, like this, open, like this, open, and so on. This is my 0, 1, 2, and 3. I have to go beyond this as well. So yeah, this value is 1, 2, and 3. Okay, let's break it like this. 0.22, 1. We all know in this range it will be simply 0 plus 1 to 2. We all know this value in this range will become what? 1 to 2 will be 1. So right here 1 dx plus 2 to 3. We all know 2 to 3. In this range it will become 2. So right here 2 dx plus 3 to 3.5. In this range we all know in this range it will become always 3. So right here 3 dx. This is 0, so don't have to worry about this. Over here, check integration will become what? X 1 to 2. Here you'll have 2 times of again x, 2 to 3, and here you'll have 3 times of against x. This is 3 to 3.5.
Understand this very clearly. This is not GIF of x. This is not GIF of x. This is the resulting value, which is x. Okay, we're gonna use the upper limit minus lower limit. So 2 minus 1 we're gonna use over here. We'll use over here as 2 times of 3 minus 2. Okay, and over here we'll use 3 times of 3.5 minus 3. Check this out. I'm getting this as 1. This is 2, and this is 3 times of 0.5. My answer is 3 plus 1.5, which is nothing but 4.5. This is nothing but 4.5. Option B. Option B. Fifth one is option B. Fair enough. Simple approach. Just break the GIF of x in this fashion. You get the result like this. Integrate. Simple integration. It is hardly take 20 seconds, 25 seconds to solve this question. If you have a good practice, 25 seconds to solve the problem. That is it. Okay. Decent enough problem. 2017 PYQ. Question number 6. 1 upon 1 plus e power x dx is equals to what? No problem, sir. Let's solve this problem. Okay. I have this, no? I can write this as 1 plus e power x minus 1 divided by 1 plus e power x, right? Correct, no? This is correct, right? This is fair enough. I'm just trying to make something where I get a form of exponential and log. Okay, superb. So I can see there's a 2 form over here. If you take partition over here, 1 plus e power x upon 1 plus e power x, and I get 1 upon 1 plus e power x dx. Okay, this is good because I have this form log with e power x plus 1, e power x plus 1. I can see this being formed at multiple occasions. This is cancelled. So what I have left with, integration of nothing but means just dx minus integration of 1 upon 1 plus e power x dx. What is this going to be? Simply x minus, over here you'll have ln of 1 plus e power x plus c. Now, so this doesn't match any of the form. You can see in all the 4 options we have a log with the quotient rule. Okay, log this by this and all. This can only happen if this also was in the form of log. How do you write this in the form of log? Ln of e power x. Ln of e power x is what? Simply x. Ln of e power x is what? Simply x. Okay, so you can write over here ln of 1 plus e power x plus c. Ln of e power x and ln of 1 plus e power x is nothing but ln of e power x upon 1 plus e power x plus c. This option will match to option C. That's your correct choice. That's your correct choice. Very simple, a very quick question. You can get it done in 30 to 40 seconds. If you have not practiced it also, if you practice, you can get it done within 20 seconds. But a smart problem, because the final result doesn't come with the form of log. You got to apply yourself your learning of logarithms to get the result of x. Replace x as this. Why do we do that? Because we have everywhere quotient form applied. Making sense? Superb. Question number 7. Okay. Again, this is a particular function form. We have to make the perfect square. Let's try working on that. So we have something like this. 3 is there. I'll take minus sign common. Can I take minus 9 common? Yeah. I need to make this free from the constant coefficient. So minus 9 is common. I get x square positive. I get plus 6 by 9x. Okay. So far this is good enough. All right. Let's worry about integration later. 3 is there. Minus 9 over here. I get x square. I need to make the 2ab term now. This is a square. Check here. I can make this very easily. 2 times of x. This is cancelled, right? I get here as 2, here as 3. 3 2 is 6, 3 3 is 9. So I have 2 by 3. How? What are you going to multiply with this to make 2 by 3? Simply 1 by 3. Fair enough? Please check. In this form, I have 2 by 3 here. So this is my x square term. This is my 2ab term. So 2 into a into b. So what are you going to multiply as b to get 2x by 3? 1 by 3. So if b is 1 by 3 means I'll have b square as plus 1 by 9. Plus 1 by 9. B square as plus 1 by 9. So I have to, if I've added something, I have to remove that as well. So minus 1 by 9. Okay. So far so good. Next, continue please. One more step to make this thing sense. Okay. Yes, I have 3 over here.
But if I move this minus 1 by 9 outside the bracket, it will become what? 9 into, please check, it will become what? Minus 9 into minus 1 by 9. I'll have this cancelled, this will become plus 1. So it will become plus 1. This whole thing will become plus 1. Okay, so plus 1 and plus 3 will make 4 minus 9, and I have x plus 1 by 3 the whole square. X plus 1 by 3 the whole square. Okay. All right. Now we have to make some substitution over here. 1 second, guys. Yes, we have to make some substitution over here. For that, what do we have? Okay, 9 is there, right? But it is simple only. I'll tell you why. Because I can write this as 1 upon 2 square. Okay, and I can write this as minus 3 upon x plus 1 by 3 the whole square. Because 9 is there, no? I can write this as 3 into x plus 1 by 3 the whole square. Now check. Yes. Take 3 times of x plus 1 by 3 as t. So, you know, this will become what? 3x plus 1 equals to t. Differentiate this, guys. You'll get 3 into simply, what is it? Dx by dt equals to 1. Because 1 will be 0, x will become dx by dt. So, I'll have 3 dx as dt. So, basically, I'll have dx as dt by 3. I'll have dx as dt by 3. Okay, so if I use this now, I'll get what? I'll get dx as dt by 3. So I'll write 1 by 3 outside. Integration, this will be dt. Root will be there. So 2 square minus t square. Okay, 2 square minus t square. This is making sine inverse form. We can continue like this. So 1 by 3 sine inverse of the t value upon 2. And what is the t value? T value is here. Please check. T value is 3x plus 1. So 1 by 3 sine inverse of 3x plus 1 by 2 plus c. This is my answer. A very good question. A very, very good question. Okay. Just usually what happens, so we take this 3 outside, we take this 9 outside. That also you can do, no problem. You can take this 9 outside, that also will work. You'll get 2 by 3 and you will get the same result. But in this, if I take this directly in over here, 3 times of x plus 1 by 3 as t, I get 3x plus 1 as t. Differentiate, I'll get 3 dx by dt as 1. It means dx is nothing but dt by 3. Replace it, you'll get the answer option C. Option C. I hope this made sense to all of you. Have a look, guys. Yeah. Question number 8. E power sin x plus 1 sec x. Right now, this question looks difficult. But if you do one step, this question becomes very simple. What is it? Bring this sec x into the numerator. Check this out. E power sin x plus 1. And sec goes in the numerator becomes cos x dx. Now, anybody can tell from here, it is nothing but sin x as t, my substitution. Sin x equals to t is substitution. So I get cos x dx as dt. Cos x dx as dt. Cos x dx as dt. Okay. Check here. My question transforms now. Et t plus 1 dt. This is nothing but an application of by parts. We all know how to solve it. Islet is a preference order. Algebra has the preference over exponential function. So algebra will be kept as it is, t plus 1. Integrate exponential function e power t as it is, minus sign. Integration of derivative of t plus 1 will be nothing but 1. Derivative of this will be 1 only. And e power t remains as it is with dt. One last step, guys. So I have e plus 1 with e power t minus integration of e power t will be simply e power t. Take e power t common. I have t plus 1 minus 1, 1 gone, of course plus c is there. Okay, so I get e power t into t plus c. Put the value of t back, e power sin x into sin x plus c. E power sin x into sin x plus c. Question number 8, option A is correct. Question number 8, option A is correct. Any problem? Any problem so far? I don't think so. Okay, I know the questions are difficult, complicated, but with the approach I'm giving to you, if you follow it properly, it will be very, very easy. Okay, please check. Okay, sir. Question number 8 is done. Ninth one now. Now this is a very beautiful question, very beautiful question, because you're going to use properties of definite integral over here, and you have a application of your different integrals, calculation also is there, and all of that. Okay, so this is a very good question. Let's see. And this is a time taking question. It is not a, like we can solve in 5 seconds, 10 seconds. It will take close to 1 or 1.5 or 2 minutes also sometime, because of the calculation requirement of this problem. Let's see. First of all, mod is there. First of all, mod is there, means it will be always positive. So if you replace x by minus x, what happens? The function f of minus x will come out as fx only. It is an even function. Listen to me. If you replace x by minus x, f of minus x will become what? X only, because f of x only, because it is a modulus function. So always positive. Always positive. It means that this is an even function. This right here is a even function. So this whole property will become what? 0 to 2, 2 times, and we have left what? X cos of pi x. X cos of pi x. Now, of course, this will be in the modulus. Forgive me, guys. This will be in the modulus. My bad. Yeah. Okay, the function. Now we're going to open the modulus with the help of branching of the limits. So we'll keep the 2 outside first of all, without any problem. Now, in 0 to 1, think about it. 1 or 1 by 2? 1 by 2 actually. Because cos graph you see over here, do you need to worry about x actually? No. Because x is going to be 0 to 2, no? The limit is 0 to 2, x will be positive. Listen to me. Limit is 0 to 2, x is the value 0 to 2, positive. Listen to me. X in 0 to 2, positive. So don't worry about that. Only worry about cos pi x. Graph of cos. Okay. So 0 to pi by 2 it is positive. Pi by 2 to 3 pi by 2 it is negative. And till 2 pi it is positive. Making sense? Yes. Now we are going to branch it out in that fashion only. 0 to 1 by 2 first. I'll have here positive x cos pi x. Positive x cos pi x. Okay. Of course, we have dx over here. Then in 1 by 2 to 3 pi by 2, this is nothing but, if you put 1 by 2 over here, it will become cos pi by 2. If you put 3 by 2 over here, in place of x, it will become cos 3 pi by 2. So it will be negative. So we'll have a minus sign. So 1 by 2 to 3 by 2, this will be negative. So I have written here minus sign, x cos pi x. And the last one, plus sign, again 3 by 2 to 2, x cos pi x dx. This is also having dx over here. I hope this makes sense to all of you. Is it clear or not? So far it is clear. What did I do? Just branched out the, first of all, I converted this into even function understanding, and 0 to 2 I wrote this with 2 outside that, okay? The property of different integral. Then I used the branching of the limits to understand where it is positive, negative with the help of the graph of cos x. Okay, this is the graph of y equal to cos x. Okay, then what I do? I have to integrate. See, you can see that the integration is always same, x cos pi x. So why don't I integrate it separately? Okay, let me integrate this x cos pi x separately. So we know that I let, again, algebra has the preference over the trigonometry. So x will be as it is. Integration of cos will be what? Sin pi x by pi. Sin pi x by pi. There comes a minus sign. Derivative of x will be 1. You have over here sin pi x by pi. One last time we have to integrate the last part. We have x sin pi x by pi, sin pi x by pi. Okay, and this integration of sin will become what? Minus cos. So minus is outside, it will become plus cos pi x by, one more pi will come, so pi square. I'll repeat the last step. Integration of sin pi x will become what? Minus cos pi x by pi. So another pi is coming, it will become pi square, and minus cos pi x with minus sign will become plus cos pi x. This is the final answer for the integration. And now in this, you have to apply the limits. Okay. One time you're going to apply from 0 to 1 by 2, 1 by 2 to 3 by 2, and 3 by 2 to 1, 3 by 2 to 2. And when you do that, you'll get this result. You'll get something like this. See, 2 is outside. When you apply the first one, this first one, I'll show you the first one. What I have x sin pi x by pi plus cos pi x by pi square. Let me apply the first limit and show it to you. What is it? 0 to pi by 2. 0 to 1 by 2 actually. Apply 1 by 2. So I'll get this as 1 by 2 for x, and of course we have pi over here. Sine pi by 2 will become 1. Sine of pi by 2 will become 1. So I get 1 by 2 pi. Okay. You can see the same thing so far. And apply for this part, it will become cos pi by 2. So simply 0. Cos 90 is what? 0. Okay. Next apply 0 over here in the lower limit. Cos, this is 0 over here, and this is also 0. So this is 0. And the last one with the plus sign I have, what I'm getting? Cos pi. So cos into 0 will be 1. So 1 upon pi square. Simplify this. You'll get 1 by 2 pi minus 1 upon pi square. This is the first one. Okay, same you're gonna do with this part and this part under the limit 1 by 2 to 3 by 2, 3 by 2 to 2. Okay, you'll have this result. When you simplify this, check here. This over here will cancel. This one, you'll have 3 plus 3 is 6 plus 1 is 7 plus 1 is 8. You'll have 2 times of 8 upon 2 pi. 8 upon 2 pi. 2 and 2 will cancel. You'll have the answer as 8 by pi. 8 by pi. Option A is correct. Clear? Question number 9 is clear. I told you in the beginning only this question will be little bit calculative. It'll take 1 to 2 minutes to solve it. I took more time because I had to explain it to you. But if you have practiced this question couple of times, then you can solve it within 2 minutes. But it will take some time. Because of the nature of calculation, it's a PYQ, so you cannot skip it also. And there will be no trick in this particular question. Unfortunately, you have to do this problem. If you're good, if you're prepared well, you can do all the steps in your mind also. It happens. That's how toppers deal with it. Okay, they have solved this question 5 times, 6 times. They'll know what is the answer directly. Okay, so question number 9, answer is option A. Please check. I hope this is all visible to you. Okay, question number 10 now. Beautiful. So what about this problem, sir? I can take this. Let's do one thing, multiply everything by e power x. If I do that, I'll get e power x dx. I'm multiplying by e power x, right? I'll get e power 2x. I'll get 1 over here. What I've done, I've multiplied this whole thing by e power x by e power x. E power x by e power x. Got it? Okay, sir. Now take e power x upon e power x the whole square plus 1 dx in this format you take. You take in this format, okay? Take in this format. All right, sir. I'm not writing the limits right now. I don't want to write the limits. I'll deal with that later, okay? So e power x upon e power x the whole square, because e power 2x is there. E power x the whole square plus 1 is there. Okay, sir. Now the substitution. E power x equals to t. The derivative will be what? E power x dx will be dt. Will be dt. Check this out. So I get this form as dt upon 1 plus t square integration. Answer is what? Tan inverse of t's. Okay. And what is it? Tan inverse of e power x. From where to where? The limit again, since we have put back the original variable x, the limit will be same as 0 to 1. Put it back now. Tan inverse of e power 1 minus tan inverse of e power 0. E power 0. So this is nothing but tan inverse of e minus tan inverse of 1, right? So that's pi by 4. E power 0 is 1. E power 0 is 1. So it will become tan inverse of 1, which is pi by 4. Answer is option B. 10th one, answer is option B. Clear? 10th is option B. Next we're gonna have to deal with question number 11. 0 to 1 by 2 dx 1 plus x square root of 1 minus x square is equal to what? Okay. So I have a root over here in this format. Of course, I need to use sine or cos only, because 1 minus sine square will become cos square, and then I can get rid of the root. Okay. Let's try this. X equals to sine theta. Then I'll get what? Dx will be equal to what? Dx will be equal to cos theta d theta. Okay, correct? All right, sir. Now substitute over here. Forget about the limits right now. Substitute over here. I'll get cos theta d theta upon 1 plus sine square theta, okay, and this will be what? This will become 1 minus sine square. Sorry, 1 minus sine square will become cos square. In the root will become simply cos theta. So cancel. Integration is over here. Now do one thing. Divide everything by cos square. Yeah, let's try this. I'll get what? Cos square. This will have sec square theta d theta, and over here I'll have 1 plus tan square theta. Excuse me, not 1 plus. I'll have sec square plus tan square theta. I'm dividing by cos square. No, it will become 1 by cos square. So I'll have sec square theta plus tan square theta. Okay. All right. One more time. I'll write sec square in terms of tan square. So I have sec square theta d theta divided by, what is sec square? Sec square is nothing but 1 plus tan square theta. Add these two together, you'll get 1 plus 2 tan square theta. 1 plus 2 tan square theta. Okay. All right. So now what I have, I can take tan theta as t. Tan theta as t. Okay. So what I'm gonna get then? Okay, better we can do. Let's take root 2 tan theta as t. Root 2 tan theta as t. Okay. Now differentiate it. So I'll get root 2 as it is, sec square theta, and over here I'll have what? D theta equals to dt. So I'll get sec square theta d theta will be equal to dt by root 2. Sec square theta d theta is equals to dt by root 2. What I've done over here, I've taken this whole thing, root 2 tan theta, as my substitution. Okay, something is making sense now. Please check. I can transform it again. So I have this as simply dt, and 1 by root 2 is outside. 1 by root 2 is outside. And over here I have 1 plus t square basically. 1 plus t square, there's a formula for this. Tan inverse of, what is it? T, simply, tan inverse of simply t. Correct, no? Yeah. Then what is the t value? Write it over here. 1 upon root t. Tan inverse of t value is root 2 tan theta. Root 2 tan theta. Now, I need to get the result in the form of variable x. Substitute theta. So, if sin theta is x, means cos theta will be a root of 1 minus x square. Root of 1 minus x square. Correct? So, put it back now. Over here, check this out. 1 by root 2 is there. Tan inverse of root 2 as it is. Okay. And tan theta will become what? Tan theta will become 1 upon, sine upon cos, no? So this will be simply x upon root of 1 minus x square. Now we can put back the limits from where to where? 0 to 1 by 2. 0 to 1 by 2. See, once I got the given result in the form of original variable, I can switch back the limits. Okay. So if you want, you can change the limit every time. But there's a chance of making mistakes in that. If you want, you can do that. You can change this 1 by 2 to 0 from x to theta when you're changing. No, you have to change the limit one more time over here. Then you have to change back again when you're using t as well. That also will work. But I use this method. You can use the other one as well. Whichever is faster for you, you can use that. Okay. And without making any mistakes. Okay. So now put the value back in. 1 by root 2 is left over here. Tan inverse is as it is. Okay. Root 2 is over here. X will be what? 1 by 2. And over here I'll be what? Having 1 minus 1 by 4 in the root. For 0 will become everything 0. No, if you put lower limit as x0, everything is 0. So that is not required. Tan inverse is outside. Check this out. Root 2 is as it is. 1 by 2 over here in the fraction form. And 4 minus 1 will become what? 3. So 3 by 4 root. I'll get root 3 by 2. Correct, no? 4 minus 1 is 3. 3 by 4 the root. It will become root 3 by 2. 2 and 2 is cancelled. My answer is now clear. Tan inverse of root 2 is left in the numerator and root 3 in the denominator. So I think we have the clear answer now. Yeah. It's calculative question. Can't be done anything about it. So option A is correct. It's a PYQ, so they expect you to solve this question. That's why I've taken it over here. Okay, got it? Yes, let's move on. Next question, 12th one. Have a look one more time. And we're going to move on to question number 12. Here you go. X cube sine 3x dx. Now this is a simple application of by parts, but more than once, because we have x cube over here. If we had only x, then differentiating x will give me 1, so we don't have to worry about that. But in this case we have to do it more than one time by parts, but that is not going to be difficult. You'll see just by solving one step, cross check this options. You don't have to complete the answer. Okay, let's start. Again, we're going to use eyelet. So algebra has the preference, so x cube will be my first function. So x cube will be kept as it is, and you're going to integrate sine 3x. That will be what? Minus cos 3x divided by 3. Check the first step. All of these are same. A, B and D is same. X cube cos 3x by 3. So this option C is gone. Next, there's a minus sign. Derivative of x cube will be what? 3x square. And you'll have the same thing. So minus cos 3x by 3. This 3 and this 3 is cancelled. We have dx over here. Now, let's forget about this because this has already been taken care of. This has already been taken care of. We're going to work on this now. So this is going to be minus and minus. So plus integration of x square, and we have cos 3x dx left now. This first thing is already matched. A, B, D can be there. Only we're going to work on this one. Integrate this. So for this, we'll have x square again as it is. And integration of cos will give me sine 3x by 3. Okay, now check. X square sine 3x by 3. Which option is there? So this is negative. So this is also gone. We have x square sine 3x by 3 here and over here also. So these two options are correct. There comes a minus sign. Derivative of x square will be 2x. And this will be as it is, sine 3x by 3. Again, we have dx. So just not worry about this because this has already been taken care of. We're going to only worry about this step. Okay, so minus 2 by 3 is there. Integration of x sine 3x. X sine 3x dx is left. Okay, all right. So minus 2 by 3 is over here. Integrate this step. X as it is. I'll have sine 3x nothing but minus cos 3x by 3. So if you check carefully, again you'll have some thing to be done over here. 1 into the same thing will repeat, but will not require. Check here. Minus into minus. That's simply plus. So plus 2 by 3 x cos 3x and by 3 is there. It means 2x cos 3x by 9. So now you cross check and see over here. So one of the bracket is this one. Okay, I can change the color. Okay, change the color. First option is this one. Second term is this one, and third term is this one. Now cross check. X cube minus x cube cos 3x by 3. So A, B, D is the option. Next, x square sine 3x by 3. So B and D is the option. Okay. Now next, we have, what is this? Sine is going to be plus 2x cos 3x by 9. 2x cos 3x by 9, only 1 is there. This is plus, this is minus. Okay. It means option B is correct. The 30 to 42nd question, yes, you have to do the steps like this and work smartly to get the result quickly. Okay, 12th is done. Question number 13th now. Yeah, cot inverse of x minus 3 to 3, we have to solve it. How are we going to do that? Very simple. Use this formula. Cot inverse of x is nothing but, what is it? Sorry, this way. Tan inverse of x plus cot inverse of x is pi by 2, I guess, right? Yeah. So I can write this cot inverse as pi by 2 minus tan inverse of x. Okay, pi by 2 minus tan inverse of x. All right. Now we know very well that I can separate it. Minus 3 to 3 pi by 2 dx minus minus 3 to 3 tan inverse of x dx. This is 0 because tan inverse is going to be an odd function. This is your odd function. Okay, for odd function minus a to a, integration is always 0. Okay, now this will become what? Pi by 2 is a constant outside. Integration will be simply x from where to where? Minus 3 to 3. So my answer will be simply, check here, pi by 2 3 minus of minus 3. So pi by 2 into 6, answer is 3 pi. 6 pi by 2 is 3 pi. Option A is correct. Question number 13, option A is correct. 3 pi. Correct. 13 is option A, 3 pi. Clear? Yes. Yeah. Clear, no? Why did we do what we did? Because tan inverse of x is odd function. We can remove that by putting it as 0. Question number 14 now. 1 upon root of x plus, there's a 2 plus over here. We're going to remove one of those. Okay, x plus root x. How will you solve this question? Let's try this way. 1 dx is there. Let's take this root x common. I'll have 1 plus x left. Okay. All right. I think this is going to be a very easy problem. Root x as it is. I'll write this as 1 plus root x the whole square. Now this is very simple. Take root x as t. Derivative will be what? Tell me. 1 by 2 root x, and we'll have, of course, dx over here as dt. Okay. Continue now. I'm getting this as dx upon root x actually. Dx upon root x actually is what? Is 2 dt. Is 2 dt. Okay. Now substitute in the question. From here you check. I'm getting this as 2 dt because dx upon root x is over here. Yeah. This is over here. Okay. So I get this as 2 dt, and this will become what? 1 plus t square integration. We know this answer, tan inverse of t. So 2 times of tan inverse of root x plus c. Root x plus c. Option is D. Question number 14, option D is the right choice. Have a look. Clear? 14, this is option D. 15th now. This is clear? This now, 15th one. 2x minus 1, we have linear by cubic over here. 3 variables will be there, of course. Let's break it down. 2x minus 1 upon, this is there, no? This bracket. These 3 brackets are there. I'm going to arrange it as a upon the first one. X minus 1 plus b upon second one. X plus 2 plus c upon x minus 3. Okay. Now if I take the LCM over here, I'll have a times of x plus 2 into x minus 3, b times of x minus 1 upon x minus 3, and c times of x minus 1 upon x plus 2. Of course, both sides will have the same denominator. We'll have the same denominator. Now in this, very simple, you have to just identify the values of a, b, c. And how do you do that? By putting the values of x in such a way that you can eliminate the other two. So if I take x value as 1, value of x as 1, then this will become 1 minus 1, 1 minus 1, so 0. I'll get what over here? Check this out. I'll get this as 2 into 1, so 2 minus 1. The LHS side is going to be 2 minus 1, and over here you'll have, I've taken x as 1, no? So a into 1 plus 2 is 3, and 1 minus 3 is going to be what? Minus 2. So I'll have a value as, please check, 1 upon minus 6 is a. So a value is 1 upon minus 6. Okay, so see, if you integrate this now, you'll get log of x minus 1, log of x plus 2, and log of x minus 3 with the coefficient a, b, c. Same thing is given over here, a, b, c with the log of x minus 1, x plus 2, and x minus 3. Okay, so basically they're asking the value of a. So a is coming as minus 1 by 6. So we have two options, either this or this. Let's find b now. To find value of b, I have to eliminate a and c. So you can see here, if I put x as minus 2, this is cancelled, this is cancelled. X is minus 2, if I put, the first and last is cancelled. So use over here x as minus 2. So you'll have over here this as 2 into minus 2 minus 1. And this will become what? A into 0. And you'll have b times of, minus 2 you put, right? So minus 3 and minus 5. Minus 3 and minus 5, correct? No? Minus 2 into minus 2 and minus 1 is minus 3. Minus 2 and minus 5 is minus 2 and minus 3 is minus 5, and that is also going to be c into 0. Check here, minus 4 minus 1 is minus 5, and we have b into, what is it? 15. So b will become what? Minus 5 upon 15, so minus 1 by 3. So a is minus 1 by 6, b is minus 1 by 3. So what is the option? Excuse me. Is it right? Minus 4 minus 1 minus 5. Okay, something doesn't seem right. 1 second. Is the option D correct or option A correct? Because they're both having this. Okay, let me check. I'll just cross check. So what we have for B, if I put it, this is 0, this is 0. Minus 2 is become minus 3, minus 5. That also is going to be positive. If I put here, this is correct. Let me check the last one, okay, to get the more clarity. Let's check the last one to have the more clarity. C, so to get the C value, I will take I'll take x as 3 and 3 over here. Okay, so x as 3 if I take, I'll have better understanding from this because I'm not sure, I don't know the answer. X as 3. Okay, when I do that, I get 6 minus 1, which is 5. 3 into 2 is 6 minus 1 is 5. This is gone. 3 minus 3 is 0. 3 minus 3 is 0. So I get C times of 3 minus 1, that is 2, and 3 plus 2, that is 5. Okay, so 5 and 5 is cancelled. I get C value as 1 by 2. C value as 1 by 2. So yes, option D is the right choice actually. A is minus 1 by 6, B is minus 1 by 3, and C is 1 by 2. So actually what happened, no, I could have taken the answer from here only, but I was not sure whether A is right or D is right. I did not know the answer. So that's what I did. I just simply took the result as, I did for the last option C as well. Okay, so to question number 15, answer is actually option D. Check this out. First one is over here, second is over here, and third is over here. Okay, clear? No problem. Moving on to question number 16 now. All right. Now in this we have GIF of x square. GIF of x is, we have done those questions, but this is not GIF of x square, so we have to be careful over here. Now think about it. If GIF of x is going to be from, if x ranges from 0 to 2, this limit which is given, this limit is given from where to where, for which variable? For x. Then x square will range from where to where? 0 to 4. Please pay attention. If x ranges from 0 to 2, then x square will range from where to where? 0 to 4. Okay, sir. Now check this out. So I'm gonna break this now. 0 to 1 if I'm breaking it. 0 to 1 first of all. Then I'll get this value as 0 plus. Next will be what? 1 to root 2. 1 to root 2. Yes, 1 to root 2. Why 1 to root 2? Because root 2 is 1.414. Okay. Now, if you actually check this out, because I'm looking for GIF, right? So for x square, if you take this value, it will become what? 1 to square of 2. So 2. In 1 to 2, this will become what? X square value, it will become simply 1. It will become simply 1. So 1 dx. Getting my point or not? Please pay attention. From where x ranges from 1 to root 2, I can do it better over here. 1 second, guys. Check this out. When x ranges from 1 to root 2, x square will range from where to where? 1 to 2. In 1 to 2, what happens to x square? It becomes 1. This whole thing, excuse me, this whole thing here, 1 second, very important to understand this step. This will become what? 1. When x goes from 1 to root 2, x square goes from 1 to 2, so x square GIF will become 1. So I've written 1 dx. Clear? Okay, sir. Next I'll have root 2 to root 3. Root 2 to root 3. Check here. When x goes from root 2 to root 3, x square will go from 2 to 3 because square of these terms. So GIF of x will go and equal to 2 actually. Between 2 and 3, what is the GIF of x square? This is simply 2. What is it? GIF of x square will be 2. Check here. So right here, 2 dx. Okay, 2 dx. Last step. One more time. Plus. This time we'll have root 3 to root 4, which is how much? 2 only. Root 3 to root 4 is 2 only. Okay. Now check this out. So this is my case 1. This is my case 2. I'm going to write this case 3 now. When the GIF goes from where to where? When x goes from where to where? Root 3 to 2. So x square will go from where to where? 3 to 4. Okay. So x square in GIF will be equal to the value 3. So we have over here 3 dx. So this is how we get the different branches of the limits. Now this is gone. Let's integrate this one. I'll get what? X 1 to root 2. I'll get what over here? 2 times of x root 2 to root 3. I'll get over here 3 times of x root 3 to 2. Okay, so this will give me root 2 minus 1. This will give me 2 times of root 3 minus root 2. Over here I'll get 3 times of 2 minus root 3. Okay, so root 2 minus 1 plus 2 root 3 minus 2 root 2. Excuse me, guys. Yeah. 2 root 2, and we'll have over here 6 minus 3 root 3. Simplify this. I'll get here 6 minus 1 is 5. Minus 2 root 2 and plus root 2 will become minus root 2. Minus 3 root 3 and plus 2 root 3 will become minus root 3. So my answer will be 5 minus 2 root 2 and root 3. Option is A. 16th option is A. Please check. Okay. 17th question. 1 plus root x, okay, 1 plus x, 1 minus x in the root is there. I have to solve this question. How do you solve it? If you see this form, of course, you're going to take x as cos 2 theta. Okay, because that's a formula. So 1 plus cos 2 theta will become what? 2 cos square theta, and 1 minus cos 2 theta will become 2 sin square theta. We know this very well. Okay, so if you take the ratios of these two, one second, then 2 is cancelled. I get cos by sin as cot square theta. Root is there, means it will be simply cot theta. So I've simplified this form right now. Okay, now if you take x as cos 2 theta from here, derivative will be what? Dx equals to minus sin 2 theta into 2 and d theta. So I get this value as minus 2 sin 2 theta d theta is the value of my dx. Value of my dx. Now we're going to use all this together without using the limit form directly. Okay, we'll see that later. Or can we change it right now? We can change it right now also. When x is 0, check here. When x is 0, okay, so we'll get what? When x is 0, I get this as cos inverse of 0. Alright, let me try this right now only. Or can we do it later? Let's try doing it later only. Okay, so x is cos 2 theta. We can use it over here. Or I can do it over here only, no problem. When x is, one second guys. One second. I'm trying to change the limit straight away over here itself. So if you take this from here, theta will become cos inverse of x upon 2. Cos inverse of x upon 2. This is my theta value. So when x is 0, I'll get cos inverse of 0 will be 0 only. Theta will be also 0. Okay. And when I take x as 1, cos inverse of 1. Sorry. My bad. When x is 0, right? My bad. When x is 0 means I'll have theta value as cos inverse of 0 by 2. So it'll become what? Theta equals to pi by 2 by 2, no? So theta will be what? Pi by 4 actually. My bad. Pi by 4, not 0. Cos inverse of 0 is what? Pi by 2 actually. Okay. Now when x is 1, so I'll get cos inverse of 1 upon 2 as my theta value. It'll become 0 by 2, so basically 0. So my limit actually is now known. The limit value is over here pi by 4 and over here 0. So let's check the function now. The final integration, pi by 4 to 0. Put this back in. Dx form is also there and this is also there. This is nothing but cot theta. Okay, and we have a minus sign, minus 2 sine 2 theta d theta. Okay. Very interesting. Bring this minus sign into this limits. So this will become what? 0 to pi by 4. Okay. Cot will become what? Cos theta sin theta. I'm writing cot theta as cos by sin. And this will be as it is 2 over here. And sin 2 theta will become 2 sin theta cos theta d theta. So sin and sin is cancelled. And I have 0 to pi by 4. 2 into 2 is 4 cos square theta d theta. Correct, no? 2 into 2 is 4 cos square theta d theta. Okay. One more formula. Little bit calculative. I can write this 2 as it is outside. And this will become what? 2 cos square theta d theta. 2 is outside. 0 to pi by 4. This over here will become 1 plus cos 2 theta. 1 plus cos 2 theta d theta. Superb. 2 is outside because 2 cos square theta is what? 1 plus cos 2 theta. Again the formula of double angle. So this will become simply theta over here, and this will be what? Plus sine 2 theta by 2. By 2 from where to where? 0 to pi by 4. 0 to pi by 4. Check this out. We'll have over here 2 times of upper limit. I'll get this as pi by 4, and this will become what? Sine pi by 2, right? So I'll have 1 only, so 1 by 2. And over here, if you put 0, it will become 0. So minus 0 plus 0. Okay. Just last step, guys. I don't have space. I can write it over here. The last step. Just the last step. Okay. Just the last step for this question. Very good question. You can see the PYQ level of your KCET is quite good. Okay. So this we have 2 into pi by 4. This we have 2 into pi by 4. And we have plus 1 by 2. Expansion will give me what? Pi by 2 plus 1. Answer is option C. Answer is option C. Please check. Please check. Okay. So first step was to get the x substitution as cos 2 theta. Take theta value from there as cos inverse of x by 2. I used this 1 plus cos 2 theta formula. I got 2 cos square. Same I've used over here also. 2 cos square as 1 plus cos 2 theta. Okay. So then I got this value simplified as cot theta. Then later I had to change the differentiation also. So x as cos 2 theta means dx will get as minus 2 sin 2 theta d theta. Okay. Use this in the change of limits over here. Change limits from pi by 4 to 0. Substituting back all the values. Solving the integration. And I get the answer as this. Putting the limit value give me answer as option C. You have to practice these questions more than 2 times, more than 3 times if you are struggling in these problems. Question number 18 now. These are very good questions. Okay. The value of 1 plus x power 4, 1 plus upon 1 plus x power 6. This is an easy question, but this is a little bit out of the box. Okay. Let's see. We can see this is forming a formula. 1 plus x square the power 3. We have a formula for that if you remember. 1 plus x square power 3 is given by 1 plus x square into 1 plus x power 4 minus x square. What formula is this? A cube plus b cube is given by a plus b bracket a square b square minus ab. Minus ab. Okay. I can see 1 plus x power 4 is in the numerator. So I'm going to do what? Subtract and add x square. Okay. Check this out. So I'll have 1 plus x power 4 minus x square, and I'll add here plus x square. Okay. And separate the denominators. So what I have over here, same thing, 1 plus x square, and have over here 1 plus x power 4 minus x square, and over here I'll have simply 1 power x plus 6. What I've done, this is in the denominator only, right? I've separated the terms with the help of these two. If you add them together, this is also nothing but this and this are same thing. These two are the same thing, okay? These two are the same thing. 1 plus x power 6 I've written as this over here. Okay. So basically they are the same denominators. So if you add them, this x square and this x square will cancel each other. I'm just separating them to solve the problem. Okay. Now check this out. Integrate it. So this is going to be cancelled. And over here you'll have a formula. Check. So I'll have over here integration of 1 upon 1 plus x square with a dx, and over here we'll have plus sign. X square is there. Write this as 1 plus x cube the square. Okay. With the dx. This is nothing but tan inverse of x. And this is nothing but, check this out. Take this x cube as t. Derivative will be what? 3x square dx equals to dt. So I get x square dx equals to dt by 3. dt by 3. Now check this out. I'll have here integration of dt in place of x square dx. No, I'll have dt by 3. So 3 I'll keep it outside, and this will become 1 plus t square. Now you have the answers. Tan inverse of x plus 1 by 3 tan inverse of t. What is the value of t? X cube. Put it back over here, and you have the final answer. You have the final answer as option A, I guess. Option A is correct. Please check, guys. Option A is correct. Yeah? Correct, no? T will be x cube. So option A is the correct choice. Okay, so 18th one. This is relatively easier than the other problems. Yeah. Okay. So next, question number 18 is done. Question number 19 now. The value of minus 1 by 2 to 1 by 2 cos inverse of x dx. I've done a question like this, remember? Write this as this form. Pi by 2 minus sine inverse of x. Okay. Integrate this individually from where to where? Minus 1 by 2 to 1 by 2. Minus 1 by 2 to 1 by 2. Because this is going to be 0. Sine inverse is a odd function. Sine inverse is a odd function. This is going to be 0. So for this, you'll have pi by 2 outside. And you'll have what here? 1 by 2 minus of minus 1 by 2. So I get here pi by 2 into 1 by 2 plus 1 by 2. Answer is pi by 2 into 1. So your option will be option A. Option A. Okay, clear? Super. So this is done. Question number 20 now. Okay, question number 20 is 3x plus 1. I've done a similar question on this. Exact similar question. Please check. It was over here. Somewhere over this I have done over here. 15 and 20 is exact same question. Check. This you can see. Now check 20th question. This exact same question. Apply the same approach. Same as question number 15. Solve it. You'll get the answer as option A. You'll get the answer as option A. This will be answer. Solve it, okay? Try it from your side and let me know how you got it right in your doubt clarification session. Okay, so this is the end of your question number 20. Question number 21. Okay, the value of e power sin x sin 2x. So we have to use some type of substitution as well as expansion of sin 2x. Let's try this way. Very simple question. So we have e power sin x. Sin 2x is nothing but 2 sin x cos x. I'll write the 2 outside the integration. And here sin x and cos x. Of course, we'll have dx as it is. Next, we're gonna use what? Our substitution. For that, sin x is t, right? So you'll have cos x dx as dt. Cos x dx as dt. So this term here becomes dt. Now check the integration. So we have twice of e power t into t dt. 2 you're gonna keep it outside. We have to use by parts. I let so we have trigonometry preference over the exponential, so t will be kept as it is. Integration of e power t is e power t minus sine, then derivative of t will be 1. Okay, derivative of t will be 1, and integration of e power t is again e power t. One more time we have to integrate, that's why dt comes twice of t e power t as it is. Integral of et will again be e power t, and of course there will be a plus c constant. You can take 2 e power t constant. We have t minus 1 plus c. Substitute back the value of t, which is sin x. 2 e power sin x minus 1. 2 e power sin x minus 1, which is option D. Which is option D. Clear? Okay. Question number 21 was very simple. Next, 22. Cos x upon 1 plus ex. Cos x upon 1 plus ex minus pi by 2 to pi by 2. So how would you solve this particular question? Okay, sir, we can see here 1 plus ex is there and cos x is there. Limit is minus a to plus a. So odd even, difficult to prove. Let's try using King's rule. Nothing works means try the King's rule once. So for the King's rule, you know what we're gonna do? King's rule. Okay. Now in King's rule, what we do is basically replace x by sum of the limits. Sum of the limits pi by 2 and minus pi by 2, we have added that, and minus x. So this will be cancelled. I'm replacing x by minus x. That's my replacement. When you do that, under the same limit of course. So if this is taken as equals to I, my first equation. Please understand, very, very simple. I have taken this integration as I, and that's my first equation. Now I'm trying to write my second equation. Okay? Check. Under the same limit. Under the same limit. All right. So what do we have? Cos of minus x. And over here we'll have 1 plus e power minus x dx. Okay. So now we're going to do 2 steps at a time. Please check. This all will be as it is. Now cos of minus x is nothing but cos x, so that will be as it is. Excuse me. This will be cos x, and one more thing, we're going to multiply both the numerator and the denominator by e power x. Why? To nullify the effect of e power minus x. I'll repeat, we're going to multiply both numerator and denominator by e power x to nullify the effect of e power minus x. You'll see, so I'll get over here e power x, this will become e power x again, because e power x into 1 is e power x, and this will become what? 1, because e power x into e power minus x is nothing but 1. Okay, so far so good, and this right here is my equation number 2. Equation number 2, add the first and second equation. So when you add the first and second equation, what are you going to get? I plus I, that will be 2i, integration limit remains same. Okay, now if you add them, you will have cos x over there and plus e power x cos x over here, divided by the same denominator. Please check. Yeah, so far so good. You can take something common here. Let's try just that. What is common, sir? So we have cos x common, 1 plus e power x, and the same denominator will be there. You can see this is getting cancelled. These two terms are getting cancelled. So integration of cos is what I'm left with. Integration of cos is nothing but sin x. The limits we can write minus pi by 2 to pi by 2. Okay, this is nothing but 2i. Check this over here. I'm getting 2i equals to sine of pi by 2. 1 minus of sine of minus pi by 2 minus 1. I'll repeat, sine at the upper limit is sine pi by 2, which is 1. Sine at the lower limit is minus pi by 2, means basically we're going to make it as minus 1. So 1 minus minus 1. 2i equals to 2. So the I value is 1. And I'm looking to find what? My I value, the integration value. Okay, the integrand will come as 1, which is option number B. Good question. Not difficult, but yeah, there's a process behind it and you have to do these steps. Okay, there's no trick involved in these questions. Then you might ask me, sir, how would you solve this problem in 60 seconds? There's two ways to do it. By so many times you're gonna practice. These questions will be done in your mind because they're very simple steps. Secondly, you have to save time for these questions. One way is by practicing more and more, these questions will be in your mind. You can do the steps in your mind and get the result very quickly. Otherwise, to save time in other problems to use in the integration. This will be that only. Wherever possible to give you tricks, I want to do that. But not in all the questions, there will be tricks applicable. Okay. Log of 1 plus x upon 1 plus x square. Log of 1 plus x upon 1 plus x square. Now, how would you solve this question, sir? This is again a very good question. A very, very good question. Now, this question will take at least 1.5 minutes to 2 minutes to solve. This will take. Okay. Chaliye. Log of 1 plus x. So over here we're going to use substitution first. Take x as tan theta. Okay, why is it tan theta? How would you know it is tan theta? Because we have 1 plus x square form. This makes an identity, right? So if you differentiate, you'll end up with dx equals to sec square theta d theta. That's my derivative change. Okay, super. Now let's change the variables also. Sorry, the limits also. When x is 0, check here. When x is 0, tan is 0 when theta is 0. When x is 1, when is tan 1? When I replace x by 1, how can I make tan 1 when theta is pi by 4? When theta is pi by 4. Clear? So limits have been changed. 0, when x is 0, theta is 0. When x is 1, theta is pi by 4. Okay. Now, I'm going to rewrite this integration. So we'll write from 0 to pi by 4. We have here log 1 plus tan theta. Replace dx by this particular value, sec square theta d theta, divided by 1 plus tan square. 1 plus tan square. Now we all know this value will be cancelled because 1 plus tan square is how much? Sec square. Okay. Now this step is very crucial. So write this as integration I, integrand I, limit as it is 0 to pi by 4, and write this log of 1 plus tan theta d theta. Nothing else is left. Please check. Nothing else is left. Only this is left. Okay. This is my final integrand. Let me just box it for you for clarity purpose. All right, sir. Next, we're gonna use what? What is going to be making sense from here? I know many of you will get stuck at this point. So when nothing is working, try using King's rule once. Okay. If you don't think any identity will work, any of the by parts will be making it more complicated. Okay. If you're thinking in that way, try to use King's rule once. Some things might change. Okay. So and let's try that. Let's try that. So if I use King's rule, if I use, I'll have what? Replace x by pi by 4 plus 0 minus x. So I'm getting the replacement of x as pi by 4 minus x. Now from here, you'll have some clarity. You'll have some clarity. Please check. Okay. Now if I try this, let's try. Integration I will become what? Limit will remain same, 0 to pi by 4. And I'll have log 1 plus tan of pi by 4 minus theta. D theta is outside. We can write a formula for tan of pi by 4 minus theta. Tan A minus tan B is what? Tan A minus tan B upon 1 plus tan A plus tan B. Okay. 1 plus tan A tan B, right? Sorry. In this case, so we'll have log as it is, no change in the logarithm. And over here we'll have 1 plus tan pi by 4 is how much? 1 minus tan theta. And same thing, 1 plus tan pi by 4 will be 1 into tan theta. So I'll write this as simply tan theta. And of course, we have d theta over here. Now take the LCM. Check carefully. 0 to pi by 4 is there. Okay. Log as it is. If you take LCM, you'll have what? 1 plus tan will come over here. 1 plus tan theta plus 1 minus tan theta divided by 1 plus tan theta comes with d theta. Tan and tan is cancelled. Tan and tan is cancelled. Right? Tan and tan is cancelled. Now we have only 2 left in the numerator. So integration 0 to pi by 4. Nothing changes over here. Log 2 upon 1 plus tan theta is there. How do you integrate this part? Check this here. 0 to pi by 4. Okay, we'll have 2 integrations. First of all, we'll have log 2 d theta minus same limit 0 to pi by 4. This time log a by log b, right? So log a minus log b. So log of 1 plus tan theta d theta. Please check. Okay, so this log 2 will come over here and this part will come over there. If you check carefully, this right here is nothing but the integration I. Please check. This part and this part is same. 0 to pi by 4 log of 1 plus tan theta d theta. This is same. Means I can replace this whole thing by I. So I'm getting I equals to, please check, 0 to pi by 4 log 2 d theta minus I. Log 2 d theta minus I. Okay. Now bring this I on this side. We'll have 2I equals to 0 to pi by 4 log 2 d theta. Now we all know this. Log 2 is a constant. Keep it outside. And integration of d theta from where to where? 0 to pi by 4 will give me what? Log 2 as it is. Integration of d theta is what? Theta. 0 to pi by 4. We have the final answer now. Log 2 pi by 4 minus 0, which is pi by 4. We have 2I. I'm looking for only I, right? I'm looking for the integration value, the integrand value. So this will become what? I equals to, bring this 2 on this side, it will become pi by 8. So log 2 as it is, and we have here pi by 8. So pi by 8 log 2. Pi by 8 log 2. 2 will come over here, pi by 8 log 2 as it is. So option C is right, no? Option C is right. Please check, guys. It's a very good question. Option C is correct. Yeah, have a look. This is clear. This is clear. All good. Yes. One more time. What did I do?
taken x as tan theta. Why, sir? Because we have 1 plus x square over here. Since once that is done, we got a derivative form, limit changed. Use that in the form to get simplified version of the integrand. From there, we apply the king rule, and from the king's rule, we got this transformation over here, and then we applied the formula of tan of a minus b. Then we got this result. From here we got log 2 upon 1 plus tan theta. Applying the formula of log, we got two different integrations. This turned out to be the same integration I. Moved on the left hand side to get 2i, and this integration is going to be what? Pi by 4 log 2. Pi by 4 log 2 once we got, move this 2 over here, pi by 8 log 2. I have done all the steps so that you will not be confused, okay? You don't have to do all the steps, but I did all of it so that you won't have to be have any confusion about any of the things. Clear na? 24th question. Now this is a very easy problem. So this was a challenging one. Now this one is very easy problem. Check. Okay. So of course you can see there's a tan inverse and there is 1 plus x by 8. So clear understanding, that is my substitution. Tan inverse of x power 4 as t, derivative will be what? 1 upon x power 4 the square. So x power 8 and derivative of x power 4 by chain rule. So 4x cube dx dt. I don't want 4 over here because there's no 4 over here, because I have x cube, I have this and I have this. So let me write this as x cube dx upon 1 plus x power 8. This will be what? Dt by 4. Dt by 4. Now change the integration. We'll have 1 by 4 the constant outside. This thing and this thing will become dt. So we'll have sine t dt. Integration of sine is what? Minus cos. Right here minus cos t plus c. So cos of what? T. T is what? Tan inverse of x power 4. Now check the answer. Minus cos. Only option is option A. Minus cos t by 4 plus c. Option A. 5-second question. Okay. Next is 25th one. Next is question number 25th. Okay. The value of x square dx, x power 6, a power 6. Okay. So this is a simple one again, because you can see here we have x square dx and we have x cube somewhere over here. Take x cube as t. So 3x square dx will become dt. So I get x square dx is dt by 3. Dt by 3. Okay. So what we get over here, integration, you check now. 1 by 3 outside, we have dt as the derivative variable, and this will turn out to be x cube is t, means x power 6 will be t square, and over here we'll have what? A cube the square, because formula is what? X square plus a square. There's no formula of x square plus a6, no, right? So x square plus a square. In this case, a is your a cube. Getting it right? The formula is this one, if you remember. X square plus a square 1 by this integration. What is that? It'll come as log. So log of the same t will repeat. What is t in this case? So t plus the same root will repeat. Okay. That's my answer. So 1 by 3 log of t is what? X cube. The same root is means what? Same root is x power 6, a power 6. The question root. Okay. The question root will repeat. Now you check, guys. What is it? 1 by 3 log. 1 by 3 I have here. This is negative. I can't have negative because the formula is for plus 1 over here. Simple question, no? Very simple problem. Only thing was to do the substitution. From there you got that there will be 3. And since we are looking for 3, we have only 2 options, 3 and 3. This is negative. I can't have that. So don't need to write all these steps. After doing this, your answer is option C. Yes? Satisfied? Please have a look. Question number 26. Value of x e power x, 1 plus x the whole square. This is a simple problem. We all know wherever you have integration with e power x outside as a separate function, simply make that form of e power x fx f dash of x. Okay. This is there. This also is there. So I can write this as x plus 1 minus 1 upon x plus 1 the whole square with dx integral. One more time. Please check, separate it over here. I've replaced x by x plus 1 minus 1. I can do that. 1 and 1 will be cancelled. It will remain as x itself. Okay. Now what I have? X plus 1 by x plus 1 the whole square minus 1 upon x plus 1 the whole square
with dx. Now you can see over here, this is cancelled. I have 1 upon x plus 1 minus 1 upon x plus 1 the whole square. And by now all of you should know that derivative of 1 upon x plus 1 is minus 1 upon x plus 1 the whole square. Now this is my fx and this is my f dash of x. Okay, so what I'm getting the answer as simply e power x fx plus c. So e power x, what is fx? 1 upon x plus 1. Okay, done. Any problem? Please check. 26th option D is correct. 26th option D is correct. Okay, sir. 27th, the value of e power x 1 plus sin x 1 plus cos x. Similar form will be there, but we have to make some changes. Let's try that. 1 plus sin x, there's no point of doing it right now, but 1 plus cos x is a formula 2 cos square x by 2. 1 plus cos x is what? 2 cos square x by 2. Okay, sir. Now if you are smart, if you think like that, then your answer directly is option A. Because sir, we are getting an angle x by 2. If the angle x by 2 is introduced, it means we're gonna get a result in form of x by 2 only. So one second problem. This, if you see here, 2 cos square x by 2, of course it will be a half angle answer. So option A is correct. 1 second, question done. But if you want the answer, I'm gonna give it to you. E power x, write 1 plus sin x as it is first step and divide by 2 cos square x by 2 dx. Half angle formula, nothing different. Okay, here separate the two terms. 1 upon 2 cos square x by 2 plus sin x, right? Sin upon 2 cos, 2 cos square x, right? Of course we have dx. Now this last step, pakka. 1 by 2 will become as it is 1 by 2. 1 by cos will be sec square x by 2. Now check carefully. I'll have over here sin x as 2 sin x by 2 and cos x by 2. Half angle formula for sin. And we have 2 cos square x by 2. Done. 2 and 2 is cancelled. Cos, gonna cancel one of the cos's over here. So we'll have sin x by cos x. Sin x by cos x by 2. Basically half angle. So we get what? Tan x by 2. This is tan x by 2. This is sec square x by 2 into 1 by 2. Derivative of tan x by 2 is what? Check here. E power x 1 by 2 sec square x by 2. Sec square x by 2. And we have tan x by 2. Derivative of this will be what? If this is my fx, this is your f dash of x. That's the answer. E power x fx, right? So e power fx means e power x tan x by 2. Please check, guys. Tan x derivative is sec square and derivative of x by 2 is 1 by 2. Answer is option A. So do all the steps and get the answer, or if you have prepared enough, then you'll get the answer directly as option A. Okay, 28 now. Okay, another good question. Means when I say good, means this is out of the box problem. Means student don't prepare for this kind of question directly. It is where the concepts are applied thoroughly to get a result. Okay, let's look at this one. Okay, sir. So you can see I have a branching of 10 and 8 that I'm looking for. I10 and I8. So I have IN. This, if you check, if my n is 10 over here, this is nothing but n minus 2. Listen to me. If I take n as 10, compare these two. N as 10 means this is going to be n minus 2. So for that reason, I'll break this tan power n as tan power n minus 2 into tan square. Okay, listen to me. I have IN, I need I10. So I'll take n as 10. So what is this I8? I8 is IN minus 2. Because n is 10, 8 is n minus 2. Now I need to get this break into n as IN, so tan power n minus 2 into tan square. Check. IN will be as it is, limit will remain same. I'll just write this as tan n minus 2 x, okay, into tan square x dx. Tan square x dx. Nothing I've done. Just simply written this whole thing in the break of n minus 2 and square. Okay. Now there's a formula for tan square. So write that 0 pi by 4. This as it is tan of n minus 2x, and this will become what? Sec square x minus 1 dx. Multiply these two, please. Expansion 0 to pi by 4. I'll write terms separately. So I have tan of n minus 2 x sec square x dx. One of the terms are separate with the x square expansion. Now second integration, minus sign will come because of this minus sign. From here you check, and I get integration from where to where? The same limit, 0 to pi by 4. This time I have to multiply this to only minus 1. Okay, so I get tan n minus 2 x dx. Okay, clear? Multiplying this part into minus 1 will give me only this. Okay, now one very much clarity we need about one thing. When in was here, I had n. When in was here, I had n. Now compare. When I have n minus 2, this is basically going to be I of n minus 2. Yes or no? When I had in, this was tan power n. If I have tan power n minus 2, this will become what? In minus 2. Yes? Yes, sir. Okay. Now what about this? This I'll continue like this only, don't worry. So this I'll write like this only, 0 to pi by 4 tan n minus 2 x sec square x dx. Okay, this is in. I shall move this over here. I'll get what? In plus in minus 2. What I'm looking for. Okay, so I'll get what? In plus in minus 2. Okay, now I have to make some changes. What is the change? I'm going to apply some substitution. So when I do that, check here. When I take tan x as t, what is my derivative? Sec square x dx as dt. This part here will become dt. Okay, but limit has to be changed. We'll do that as well. Check first. I'll get what? This will become t power n minus 2, and this will become dt. Limits, sir. Limits, sir, please. Okay, limits, here we go. Limits, here we go. Check the limits now. Okay, so when x is 0, I have taken tan t as tan x. This is not alpha. Okay, I hope you get it. This is tan x. Okay, so when x is 0, tan 0 is what? 0. X is 0, tan x I have taken as t, right? So tan 0 will be 0. When x is pi by 4, what's my t? Tan of pi by 4, so 1. The limit will be what? 0 to 1. Integrate it now. It's simply polynomial expansion. So integration t n minus 2 plus 1 upon n minus 2 plus 1 is what? N minus 1 under the limit 0 to 1. You see the question is solved now. In plus in minus 2 is equals to, put the value 1, you'll get 1 power n minus 1, which is nothing but 1 only. N minus 1, put value of t as 0, this will be 0. Listen to me, put t as 1, not n as 1, okay? Because this limit is for the variable. The variable is t over here, not n. Put 1 as t, 1 power anything is 1. So this is 1. When you put t as 0, everything will be 0. So we get 1 upon n minus 1. Now what are they asking in the question? They're asking us I10 plus I8. Basically, this n is in this case 10. So 1 upon 10 minus 1, 1 upon 9. That's your result. Option D. I hope everybody is clear about all the steps involved over here. Okay. Unfortunately, there's no trick in this question again. Unfortunately, there's no trick in this question, so you have to do all the steps. By practice, trust me, this can be achieved in 1.5 minutes, like that. But it will take some time. This kind of question will take some time, and I cannot ask you to skip it because this is a PYQ. So what I've done now, I could have taken more PYQs as well, but I've taken the best ones, the most challenging ones, and these are the PYQs over here, which you will not be able to find anywhere. The PYQs themselves that I'm solving over here is difficult to find detailed solution in any other platform or other places. So these are the most important ones. Okay. Already you can see the session has gone very longer. Other PYQs that you want to solve, you can of course solve from your side. You'll get multiple places, the resources and the solutions. But these are the best ones that you need help in. That's why these PYQs are very, very important. These 40 questions are very, very important. Clear? Okay. 28th problem is done. Moving on. The value of this is a trick question. Okay, trick you're going to use and get the result. You can see King's rule will make the same, no? If you apply King's rule in this, first of all, I'll give you the answer. Answer will be upper limit minus lower limit by 2. So 4042 minus 0 by 2, that is what? 2021. Option B. Then it'll tell you the how to do it. So King's rule if you apply, so what is the King's rule going to be? Replace x by sum of the limits. So 0 plus 4042 minus, excuse me, yes, 4042 minus x. Okay, so I can replace x by 4042 minus x. When you do that, this will become what? 4042 minus x. This will become 4042 minus x. This will become simply x. When you add the two, this is going to be your equation number 1, let's say. And if you add the second equation also to 1, you'll get 2i equals to integration of x from where to where? 0 to 4042. Okay, you'll get the answer as 4042. And you have 2 on this other side, it'll become 2021. Please try. I've done a question like this, okay? Please try. 30th. Okay. Also, I've done a problem like this, but let's solve it. Let us solve it. Integration of GIF of x from 0 to 8. Now, we all know between 0 to 1, this will be 0. Between 1 to 2, this will be what? 1. Between 2 to 3, the GIF will be what? 2. Between 3 to 4, the GIF will be what? 3. Between 4 to 5, GIF will be 4. And between 5 to 6, it will be 5. And we have 6 to 7 also. So 6 dx and 7 to 8 also will have 7 dx. So we have these many integrations. 0 is cancelled, so remove this. Now check this out. Integration of 1 will give me what? X from where to where? 1 to 2. Same way. Over here also, what are you going to get? Check this out. You'll have 2 constant outside. Integration will be x. Integration of dx is what? X. From where to where? 2 to 3. Okay. Over here 3 will be constant outside. And what are you going to have? Again x from 3 to 4. Now check carefully. Check carefully over here. What is this? 2 minus 1. What is this? 2 into 3 minus 2. What is this? 3 into 4 minus 3. Check carefully. What is this? 1. What is this? 2 into 1. What is this? 3 into 1. What is this? 4 minus 3 means 3 into 1. The next will be what? 4 into 1. Next will be what? 5 into 1. And we have all the way till 7. So write the last 2. Correct now? Yes? Because every time the limit will be 5 minus 4, 6 minus 5 and 7 minus 6 and 8 minus 7. This is not looking like, excuse me, this is 6, okay? 6 to 7 means 7 minus 6 and 8 minus 7. It will be always 1. Now add it. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, plus 7 is 28. Answer is A. Clear? Easy? Yes.
So thank you all of you for joining in this session and listening to me, and do not forget to subscribe to the channel if you are new and watching me for the first time. We have more amazing things planned on our channel for all of you, whether you're preparing for KCET, for your Comet K or PU2, okay? And we also have our crash course available, PU2 crash course. Just take that if you're writing your boards next year. And if you want to enroll into a full-time course of KCET, you have available KC90, which includes both of KCET and Comet K preparation, okay? Yes, unfortunately the batch 2 went live and many students already joined in. You're going to be late, but still better now than never, right? So take the course if you are looking to prepare for KCET or Comet K. Seriously, we still have time, we still have lectures to cover, and we'll have a lot of benefits of taking the course. And don't forget to like this session if you enjoyed this particular class, and join me again in the next class of KCET. Till then, take care. Bye-bye.